Okay, welcome everyone to back about the basics complex vector computing. That is part 2. Okay, part 2. Okay, we will look more about how we can compute two vector and add or multiply or you divide two vectors together. And okay, so I hope after this video you can how calculate the two vector, add the two vector, and how you can divide two vector, or how you can the multi two vector together. Okay, if you see here we have a two vector, vector u, and we have a vector v. So this vector will be represented in the complex number or complex number. Okay, remember complex number. And because we represent in the complex number, so we have a two part. These are part 1, that is real, right? And the part 2, that is a complex. Complex value. And now we based on this value, so I hope you remember the I, this I. I's value, remember the last I will tell you I equal to the square root for the minus 1. Yeah. And if the the I square, so it's equal to the minus 1. So yeah. So it's I square is equal to the I multi I, right? So it's equal to the square root minus 1 and square root minus 1 if you wanted two values. So of course it's equal to the minus 1, right? It's similar. Over here we have either 3. So it's equal to the I and multiple I square. Yeah. So because we know the I square is 1 minus 1, right? And yeah. So it's you can see is called multi I. Yeah. Because we already know about I equal to square root to the minus 1. Sorry. Yeah. Okay, this is kind of actually I hope you only need to remember this part. Yeah, this part. The other part you can calculate very easy. Yeah, something like this you can follow this one how I calculate. Yeah, because remember this one maybe look very confusing to you. Yeah, something you lost understand. Yeah. Okay, so the second part. Okay, we have conjugate. This one is a little bit, it's kind of little bit confused with all of you. Okay, we have two, this is x, this is y, something I want to give example. Okay, and conjugate this is, for example, this is u, and we have conjugate, right? So conjugate that is u. Okay, you can see. So actually, it's a opposite the x coordinate. Yeah, coordinate. You can see. Actually, this in the future you will see this quite two the angle would be similar. Yeah, two similar. So okay, this conjugate. Remember, and the value conjugate when we calculate actually is only change this value. Okay, change this value. You see, after we conjugate, we have a minus b y. Yeah, so only to change change that value, and we have to add to the values to the vector. So if about the u plus the v, so what about the difference? So actually, it's very simple. You can for example, over here we have u plus v, so you can move to that value a dot by c di. So over here because we have ac, right? A plus c, because this one is a real number, so we can move together. And this is a bd, so BD, so we can plus PD, this, yeah, DI, right? So A plus C, B plus DI, right? So yeah, this value you can see. Yeah. So actually, this is a kind of you know, the symbol, and when you move to this way, so you can see this one real, and this kind of the complex number, okay, complex number. To make sure after the value for plus 2 vector, we have a same format like the original one. Yeah. Okay, so about the multiplication. U multiply with V. Yeah. Okay, this one is a kind of a little bit more complicated. Yeah. We will look more detail like this. I want to step by step. Okay. First is U equal to the A dot B I, right? U V equal to the C D I, right? So now we multiply 2 vectors together. U, right? So it's you can this part A and C D I, something like this, and you multiply this one, the whole, this one and this one. So we have A C, right? This AC and B plus B C I, right? That's first half. And the second part you can similar. You can multiply this one and this one. So you can have A D I, right? And we have this is B I D I, right? Yeah. So if after that we have, because we have the values for BDI, so DI this is equal to the square. So we have AC minus, you know, BD, because you know, I square equal to the minus 1, right? Yeah. And over here we have we can BC AD I, yeah. So that is this kind of yeah, is equal to this one. Yeah. Actually, to multiply multiplication, this value is kind of quite easy. You only need to you know, you can multiply the 2 value, and it's equal to the, you know, when you have you stay in the high school or the secondary school. You already learn about this part. Yeah, it's so easy. About the you know, the U square. So U square have a kind of very special. We need to have 2 the vectors. This is U and this conjunct yeah, conjugate. Okay. In previous slide, we already tell about conjugate. So conjugate, if we have A, yeah, this is U vector U, the A plus BI. So after conjugate, we only change this kind of value. Okay. Yeah, this is equal to the minus. So very special. After you calculate this multiply 2 value to the vector like this, and you can follow the same mechanism like this, and the final value you can get this one. Okay. Yeah, the same mechanism. Yeah. And about the division, this one have a kind of very special division. We can base on the multiply. Okay, multiplication. You see over here we can have you know, this is from the this part, right? This part. But we do not know how to divide 2 vectors. So we can move to, you know, to the multiply first. Multiply, so you can see we can multiply with the same vector conjugate. Yeah, conjugate the vector UV. So this one, if this one to divide this one is equal to 1, right? So it doesn't change the value, right? Okay, so after you after you u multiply with the conjugate vector v, so yes, this one. So because conjugate is c di, right? So yes, after we multiply this u and is equal to this value, yeah, and yeah, actually it's partial over here. Remember, we have two the vector. If the vector v multiply with the conjugate vector v is equal to the this value from the previous slide. Okay, this one how to calculate the this v square. Yeah, and about the normal length on a vector is this kind of normal or length. The length of vector is equal to the square root for vector u and the conjugate vector u. So actually we can do very quickly by equal to this one is this one. If you see the previous slide you can have this value. So so this is equal to the square u square equal to the u and u conjugate. And okay, so and this is a kind of example how we can multiply with two vector. Yeah, the first one is actually it's a very simple. It's equal to the this one. We will multiply this one and this one first. That's the first step. And the second, we can multiply this one and with this one. Okay, this one is actually this one maybe have a little bit confusing, so you can add the one and yeah. So it's similar. This one is kind of have a two-way. Yeah, this the first one is second. Similar when you divide. So remember we can multiply with the conjugate v conjugate. Yeah, this conjugate. Okay, actually this v conjugate. This v conjugate. And if you see this one we change. Yeah, change the base value. And okay, this is how. After we multiply these two values, so this remember when we multiply or we divide, so we only need to see split to the value. So that's a kind. First is a real, and the third one is a kind of the complex number. Okay, remember we only we need to transfer to the two part, the value two part. Okay, actually after we have complex vector and we can calculate and we can now we can represent the complex vector in the complex lane. So complex lane is called, we can represent the real part and the complex part or the imaginary part. So over here we have this is kind of real, right? We have a real. Yes, we have a real part and we have an imaginary part. And over here, if you see this A is a real number, so yeah, the real number is equal to this part, and we have B that's equal to this part. And it's very important over here we have U. After we have we have U and A. Yeah, so or this one is U. Yeah, this one is actually it's very important. Yeah, A. And this the form is very important in future when you want to transfer to the Euler formula and in the quantum. So remember we have a two part, yeah, the real number and we have a complex number, and this part we can equal to the conjugate multiply with the other vector. Yeah. So the complex vector or complex plane, its complex plane, it will be used in complex value in the two dimension. Yeah. This is 2 dimension. And in future, when we have a quantum, this is kind of 3 dimension. 3 dimension. It's more complicated. So I hope, this part conclude how you can tell, how you can understand the basics before we can move to the more complicated version. Yeah. Okay, so in this lesson, I already tell you about how to add how to add and multiply how to divide the complex vector and complex library u dot plus v, or this u minus v, or we have u, right? That's first. The second, we can know about the conjugate u, this conjugate, and the third one is complex plane. Yes, this is very important to go to the next part. I hope you got these 3 points.